If you are too busy pulling a loaded cart with square wheels, this video is certainly not for you. If you like this video, please don't forget to subscribe my channel and click the like button. And if you find this video useful, please share this video as much as you can with your friends and colleagues. If you have not yet subscribed to this channel, please subscribe to the channel now. By subscribing the channel, you will automatically get notification of the next uploaded videos. Dear friends, welcome back to the series of videos on everything you wanted to know about fully fashioned knitting. In the last video, we discussed that to determine the neck tape length, we need to know the length of an arc, when the radius of the arc is not known, but only the cord length of the arc and the depth of the arc are known. In this video we will discuss how to make these calculations in precise and accurate way, and leave nothing to assumptions. To determine the length of the tape that has to be attached to a round neck, we must divide our calculation into two parts: the back neck profile and the front neck profile. In this video, we discuss how to calculate the length of the back neck profile and the front neck profile accurately. For round neck sweaters, we normally have shapes, namely round neck or crew neck, and the turtle neck or the high neck. All other necks, like the U neck, which has bigger front neck drop than the neck width, and a wider neck with smaller neck drop, are variations of these two. The main difference between a round neck and the turtle neck as well as a high neck is that of the front neck drop and the neck width. In a crew neck, the front drop is almost half of the neck width, and the front neck drop of a turtleneck is a little smaller than the front neck drop of the crew neck. At the same time, the neck width of the turtle's neck will be bigger. For example, if the neck width for a particular pullover size is 18 centimeters, the front neck drop normally is 9 centimeters. But for the same size pullover, the neck drop of the turtleneck of the high neck is not more than 8 centimeters. And because we have a smaller neck drop, we need bigger neck width. If we keep the neck width the same as that of a crew neck, the circumference of the neck will be reduced not by just by 1 centimeter, but a lot more, almost 2 centimeters. To compensate for this reduction in the neck hole circumference, we must increase the neck width. To compensate 1 centimeter less of front neck drop, we will need to increase the neck width by 3 centimeters. Therefore, the ideal neck width for a turtleneck or a high neck for the same size pullover, which has a front neck drop of 8 centimeters, instead of 19 centimeters, will be 21 centimeters. Normally you will see that the measurement charts increase the neck width by 1 centimeter only. This reduces the circumference of the neck by 1.5 centimeters. And because of this, in general, we find wearing a high neck pullover is a little difficult, especially when the neck of the pullover passes over the head. Should you increase the neck width by 3 centimeters, a wearer can wear the high neck pullover with the same ease. Why I say this, we will find out when we learn how to calculate the length of the profile of the back neck. We normally have a back neck drop of 2 centimeters, and we have some length as neck width. To have a perfect back neck, as per the illustration, the back neck shall have an arc of 2 centimeters by 2 centimeters on both sides, and the distance between these arcs shall be neck width minus 4 centimeters. The circumference of a circle with 2 centimeters as radius will be 2 pi r, where r is the radius of the circle. This will be about 12.57 centimeters. As radius s equal to 2 and value of pi is 22 divided by 7 or 3.14. Therefore, 2 multiplied with 2 multiplied with 3.14 equals 12.57. Half of this will be 6.29. And a quarter of this will be 3.15. If we add up the length of both the arcs, they make 1/2 of the circumference of the circle with a radius of 2 centimeters. If the neck width given is 18 centimeters, the total length of the back neck profile will add up to 3.15 plus 14 plus 3.15 equals 20.3 centimeters. Normally, the back neck profile will follow the same procedure of calculating the profile length. But when it comes to front neck drop, we always have a few variations. For front neck we can have 3 different variations. Like, my neck width can be 18 centimeters. And my front neck drop can be 9 centimeters. Or, my neck width can be 18 centimeters. And my neck drop can be more than 9 centimeters. Or, my neck width can be 19 centimeters. Or more. And my neck drop can still be 9 centimeters. Or less. If the neck drop is equal to or bigger than half the neck width, the calculation of the front neck profile length is easy. Simple 2 pi r formula will work. But if the neck width is bigger than the front neck drop, we need to use a different formula. Using the formula is easy. But how we create this formula needs to be understood. This is exactly what I talked about in my last video, where I asked, how many of us know how to find the radius of the arc when we only know the length of the chord and the depth of the chord, which are represented by the neck width and the front neck drop respectively. But first, let's understand the simple one, where the neck drop and half the neck width are the same or almost the same. If you look at the illustration, you can see that the neck width of 18 centimeters and a front neck drop of 9 centimeters makes the neck profile the same as that of a semicircle with a radius of 9 centimeters. Though this is not an ideal measurement for a round neck pullover, nevertheless, it is the best way to understand the calculation of a round neck. Here is a simple formula. 2 pi r, which gives us the circumference of a circle, becomes useful. Using the same formula, we can easily calculate the length of such an arc or semicircle by just using pi r. Because the neck is a perfect semicircle, the length of the front neck profile in this case will be 3.14 multiplied with 9, which equals to 28.3. In the second case, we have the neck drop bigger than half the neck width. If you look at the illustration, the neck width is 18 centimeters and the neck drop is 10 centimeters. So, in this case we divide the neck profile in 2 parts. A semicircle with 9 centimeters radius and a rectangle of 18 centimeters width and 1 centimeter height. The circumference for a semicircle with 9 centimeters radius is 28.3. And we add 1 centimeter each from both sides to make it 30.3 centimeters. The front neck profile will therefore be 30.3 centimeters. Similarly, profile lengths where drop is bigger than the half neck width can be calculated by dividing the neck profile in 2 parts, a semicircle and a rectangle. We now come to the most awaited part of finding out the length of an arc. So formed by the neck width, which is larger than twice the neck drop. If you look at the illustration, we have a neck width of 21 centimeters and a neck drop of 8 centimeters. And we need to know its arc length, while we have no idea what is the radius of this arc. To find the radius of this arc, we will need to understand its geometry. There are 3 different ways to find the value of radius, but we will discuss only 2, as the third one is more complex. The remaining 2 methods are: one is using the Pythagoras theorem. The other uses the geometry of circles and chords. As per Pythagoras theorem, if you look at the illustration, alpha is equal to the neck width, which is equal to 21 centimeters, and h is equal to the front neck drop, and this is equal to 8 centimeters. To use the Pythagoras theorem, we need to create a right-angled triangle. So, we would draw a perpendicular from the imaginary center of the circle on the chord alpha, which we know. This perpendicular, if we extend till the circle lower end, will do 2 things. First, divide the chord in 2 equal parts. And second, it will create a line equal to the radius of the circle. We also know that the radius of the circle is now divided in 2 parts as shown in the illustration. H and R. H equals the neck depth, and R equals the radius of the circle minus h, the neck depth. As per the Pythagoras theorem, we know square of R equals square of R plus square of C divided by 2. We know R is equal to R minus h. Therefore, square of R equals square of R minus h plus square of half the C. Solving square of R minus h using the formula square of A minus B, we get square of R equals square of R plus square of h minus 2rh plus square of half the C. We nullify square of R from both sides of the equation, and we get square of h minus 2rh plus square of half the C is equal to 0, or 2rhi equal to square of h plus square of half the C, or R is equal to square of h plus square of half the C divided by 2h. As we know the value of R and small r, the angle phi in radians will be the inverse cosine of R divided by radius capital R. Therefore angle phi in radians will be twice the a cos of R divided by radius capital R. The length of arc formed by the angle phi is equal to R multiplied with phi. To calculate mathematically using the formulas we derived at, the neck width represented by C in our formula has a value of 21. C divided by 2 is equal to 10.5. The neck drop represented by h in our formula is equal to 8. If h equals 8, R equal to radius R minus 8. Using the formula for radius R, we get R the radius is equal to 110.25 plus 64 divided with 16. That is 2 hours. Equals 10.89. Or 10.9 centimeters. The small r will be equal to radius 10.89 minus h, that is equal to 8. Therefore small r will be equal to 2.89. The value of r divided wih, the radius r, will be 2.89 divided with 10.89, which will be equal to 0.265. A cos of 0.265 is equal to 1.302. The angle phi is equal to twice this value. Therefore phi is equal to 2.604. The length of arc ADB is equal to R multiplied with phi in radians. and will be equal to 10.89 multiplied with 2.604. This will be equal to 28.36 centimeters. If we use the circle and chord geometry, we will be able to find out the value of the radius of the circle or the arc. If you look at the illustration, using the geometry of a circle, we know that AB multiplied with BC is equal to DB multiplied with BE. If you look at the illustration, DF is the radius of the circle. DE is equal to 21. And as DB and BE are equal, and our 10.5 BC we know is equal to 8, AB will be equal to 2R. That is the diameter of the circle. Or AC minus BC, which is equal to 8. So AB equals 2R minus 8. R is equal to AC divided by 2. Or AC is equal to 2R. And BC, which represents H. AB is then equal to 2R minus BC. Or 2R minus H. We know AB multiplied with BC equals DB multiplied with BE. We also know DB equals BE equals half of C. Therefore AB multiplied with BC is equal to square of C divided with square of 2. Or square of C divided with 4. AB equals 2R minus H and BE equals H. So AB multiplied with BC becomes H multiplied with 2R minus H. Therefore 2RH minus square of HI. S equal to square of C divided with 4. We further simplify it as 2RH equals square of H plus square of C divided with 4. Or R is equal to square of H plus square of C divided with 4. And this sum divided with 2 times H. Solving mathematically. Using this method of finding out the radius, we know BC is equal to 8. We also know DB and BE is equal to 10.5. So 10.5 multiplied with 10.5 equals 110.25. And AB multiplied with BC. This is equal to 2R minus 8 multiplied with 8. Or 16R minus 64. So 110.25 is equal to 16R minus 64. Or 16R is equal to 174.25. Or R is equal to 174.25 divided by 16. Which is equal to 10.89. Using both ways to find out the radius, we get the same value for the radius. And that is 10.89 centimeters. And for the length of the acre, we will still need to use the Akos value to determine the angle in radians and the length of the arc as radius multiplied with the radian value of angle phi. And the length of the arc of the front neck will be 28.36. The length of the back neck profile will be 23.3 cm. Therefore the total circumference of the neck will be 23.3 plus 28.36 or 28.4. Or 51.7 centimeters. If you are afraid of these calculations, make a small Excel sheet using the necessary 2 formulas. And all you need to type in is the neck width and the neck drop, and you will get the circumference of the neck. Use another column to type in the linker value, and you know the number of needles to be used. And finally, even if you do all this correctly and forget to mark the half of the back neck, the end of the back neck, and the center of the front neck on the tape knitted, you can still have a twisted neck. To date, I have not come across any sweater knitting factory which uses this technique. There may be many factories that follow this procedure, but I have not come across any. Obviously, I have not seen all the factories manufacturing sweaters. For the V-neck, the back neck drop profile, Calculations are same as discussed earlier. For the front neck profile, if you look at the illustration, the calculation is simple. We apply the Pythagoras theorem. The front neck profile length is 2 times the square root of square of half the neck width plus square of the front neck drop. Calculating an example mathematically. If the neck width is 18 centimeters, the back neck drop 2 centimeters, and the front neck drop 12 centimeters. The front neck profile length is 2 times square root of sum of square of half the neck width and square of the neck drop. That is 2 times square root of square of 9 plus square of 12. Or 2 times square root of 225. Or 2 multiplied by 15. Or 30. The back neck profile we know is 20.3 centimeters. So the total circumference of the V-neck will be 20.3 plus 30, which equals 50.3 centimeters. If you have liked this video, please don't forget to click the like button. And if you have found this video useful, please share this video as much as you can with your friends and colleagues. If you have not yet subscribed to this channel, please do not forget to subscribe to the channel. By subscribing the channel, you will automatically get notification of the next uploaded videos. Thanks for watching. Technicians, programmers, product developers, designers, and companies interested to get the measurements of their proto samples right in the first go can also try my software for knitting data calculations. The calculations used are accurate, and you can easily make a garment with not only the right specs, but a garment that looks good and fits even better, elevating the image of the wearer. To obtain a copy, please do contact me at email purisk51@gmail.com or on my mobile number, country code 91, number 81464000900. For more detailed information, you may go through my book on fully fashioned sweater manufacturing. A Guide to Fully Fashioned Sweater Manufacturing. Published by Woodhead Publishing India Private Limited. The book is available in leading bookstores in almost all countries around the world. It is also available on Amazon. Throughout the series, your valued suggestions, as well as questions, will be welcome, and I shall be too glad to answer all your queries. You can contact me by email purisk51@gmail.com or on my mobile number, country code 91, number 81464000900.